We're going to talk about multiplying polynomials in this learning target, but we're going to move on to more complicated polynomials. Last learning target, we learned how to just multiply one term by a big polynomial. Well, today we're going to talk about what happens when we have a binomial multiplied times a binomial, so more than one term multiplied together. So I'm going to first talk about a really common misconception of what students tend to think happens when we multiply binomials. So a student will see a problem like this one, right here, with variables, x plus 2 times x plus 3. Then they'll think, oh, I distribute that to there and get x squared, and I distribute that to there and get plus 6. So this must be my answer, right? Okay, this is wrong. Okay, then I'm going to explain why this is wrong using some numbers, because I think sometimes for students it's easier to see numbers. Okay, so let's take a look at an example over here on the right. Okay, so I've got 1 plus 2 times 3 plus 4. So I'm basically saying that, okay, if we wanted to do this problem the same way as that, then we're going to say, okay, I do 3 times 1 plus, and then 2 times 4 to get 8, right? So we think the answer is 11 if we did it the same way we did in the first one. But let's actually do the math here. So let's take this out. So I'm going to rewrite it. 1 plus 2 times 3 plus 4. Well, let's actually do the 1 plus 2 here. So 1 plus 2 is 3, and then 3 plus 4 is 7, and 7 times 3 is 21. So here I got an 11, and here I got a 21. I know the 21 is correct, because I just did that adding here. So clearly, I can't do just distributing the first terms, distributing the last terms, and get the correct answer. It doesn't work. The math doesn't add up. So this here can't be the correct answer for this. All right, so that's one thing students often misunderstand when they look at things like this. They just want to distribute the thing one time. Okay, so when we have binomial times a binomial, we have to distribute more than one time. So I'm going to show you two ways to think about a problem like this. The first way is to think about it using the distributive property. So I have to distribute the x to the x, but I also have to distribute that x to that number there as well. And then I have to distribute the 5 to the x and the 5 to the 2. Okay, so we're basically double distributing. Okay, so now very carefully I'm going to do that math. X times x is x squared. X times 2 is 2x. So there's the first distribution. And then the second one is 5 times x, which is 5x, and 5 times 2, which is 10. So these two numbers in the middle, this 2x and this 5x, that's the key thing we were missing from the beginning. I got the x squared and the 10, but I need these middle terms here. So my final answer when I combine like terms is x squared plus 7x plus 10. And I have to write that in standard form. Okay, so that's multiplying two binomials. Let's do another example using distributive property. Okay, so in example B, I'm going to distribute the 2x to the x and the 2x to the 3 to get 2x squared plus 6x. So there's the first thing I have to distribute. And then I also have to distribute the, oops, let me change color here. I have to distribute the 4 to the x and the 4 to the 3. So I get plus 4x plus 12. And then I have to combine like terms. So 6x and 4x, that's going to give me 10x. Okay. Now, I think there's a much easier way to do these problems in terms of making sure you don't make mistakes. There's a way to organize our work. Okay, and remember how we did a little bit of area modeling in the last learning target? We drew the box and made an area model. So we can also area model with problems like these. Remember, area is basically saying length times width, correct? So I can say, oh, this x plus 5 is like my length, this x plus 2 is like my width. So if I were to draw a box to find area, I'd put the x plus 5 on the top and the x plus 2 on the side, because that's how to find area. I'd multiply the length times the width. So the cool thing we can do now is we can break this big box into smaller boxes and then find all these little areas. So I can first find the area of this x times this x to get x squared. Okay, so that's this guy times this guy. Then I can find this 5 times this x to get 5x right here. Then I can find this little area, x times 2, to get 2x. And then finally, that last bit of area is 5 times 2 to give me 10. Okay, and now when I see all of this together, now I have to think, okay, I want to write the total area, so it's basically all these little areas added together. And I see that these are like terms, so my final answer is going to be the x squared plus 5 plus 2x, which is 7x plus 10. Notice that this is the exact same answer I got here and I got here, because they're the same problem. But I think the area model is just a really clean, nice way to organize our work, and it limits some mistakes, because when you're drawing, when you're drawing these lines to distribute, sometimes you forget if you've done it. Did I distribute it correctly? I'm doing it in my head. And this way it's all written out and you can actually see the math that you're doing. Okay? So example B, it's the exact same problem up here, 2x plus 4 times x plus 3, but let's try it with the area model. So I'm going to draw my box. I'm going to put 2x plus 4 on top and x plus 3 on the side. It doesn't matter which you put on top or bottom. I could put the x plus 3 on top and the 2x plus 4 on the side. You'll get the same answer, so it doesn't matter. Okay, 2x times x is 2x squared. 4 times x is 4x. 2x times 3 is 6x, and 4 times 3 is 12. Now when I write my final answer, I'm going to combine like terms. These are my like terms, so my final answer is going to be the 2x squared. 6 plus 4 is 10. And then plus 12. Still the same answer I got when I distributed, but my work is a little more organized this way. Okay? So I want you to go ahead and pause, and I want you to simplify these two problems using whatever method you like. I'm not particular. As we get to harder polynomials, you're going to struggle with distributive properties, so I would try the area model. Okay? So pause the video, take about 3 minutes, 4 minutes, and try these on your own. Okay? So these are the polynomials that I got when I used the area model. For the first one, you've got a couple negatives that you have to deal with, so be careful. You're combining negative 2x and x to get negative x. And for the second example, you're going to get terms that don't actually combine. Okay, so you should have gotten 4 terms. You couldn't combine any, so this was the most you could simplify. Keep in mind, if you're struggling with your practice and don't know how to do it, and I haven't seen work for these your turn problems, I'm going to make you go back and do them. So just be aware of that. I need to see work when you actually do the you tries on my videos. Okay. All right, so let's move on to bigger polynomials. Not just a binomial times a binomial, but what about like a binomial times a trinomial? If we wanted to distribute this, it would look like this. I'd have to do x times that, x times this, x times this. Then I would have to do the 2 times that, 2 times this, 2 times this. Now I don't know about you, but that hurts my brain a little bit when I think about that. So instead of doing it with distributive property, I'm going to go ahead and make an area model with this. Now my area model is going to look a little bit different. So I've got the x plus 2 here. So this is going to be x plus 2 on the side. And then on top, I've got a much larger polynomial, so I need to make a bigger box. I've got x squared minus 5x and then plus 4. Now I have to break this into boxes like that. So instead of 4 boxes, I'm going to have 6 boxes. So you need to make your boxes the right size for what kind of polynomials you have. Okay? Now we just multiply each box. So x squared times x is x to the third. Negative 5x times x is negative 5x squared. 4 times x is 4x. Now go to the bottom. X squared times 2 is 2x squared. Negative 5x times 2 is negative 10x. And 4 times 2 is 8. Okay? Now I'm going to check and see if I have any like terms. These are like terms, the x squareds, and these are like terms. So now I'm going to write in standard form that x to the third is by itself. 2x squared minus 5x squared is negative 3x squared. Negative 10x plus 4x is negative 6x, and then bring down the 8. So I think the area model for a problem like this is much simpler. Okay, it keeps your work so organized, and I would love to see that on your papers. Okay. Let's do another one here. Binomial times a trinomial, so I'm going to go ahead and, you could also make your box like this. I don't do this very, well actually, let me try that. You can make your box look vertical instead of horizontal. So you could put the 3x minus 4 up here, and you can put the negative 2x squared, the 5x, and the minus 6 here, and you'll still get the same answer. So either way you want to make your box, as long as you've got as many terms on the sides that you need, it will give you the right answer. So this is going to become, oh, that should be a negative. So negative 6x to the third. This is going to be 15x squared, and this is going to be negative 18x. Over here, I'm going to get positive 8x squared. Negative 4 times 5x is negative 20x, and negative 4 times negative 6 is 24. Check for like terms. They tend to be on diagonals, not 100% all the time, so I'm not going to say that, but there's a pattern that like terms are diagonal from each other. So I've got negative 6x to the third. 15 plus 8 is 23, so 23x squared. Negative 18 plus negative 20 is negative 38x, and then we've just got the plus 24. Okay? Alright, so I've got one for you to try, so go ahead and pause the video, and again I need to see your work, so pause right now, try and make your area model, and see if you can get the correct answer. Alright, this should be your correct answer in standard form, if you've written it correctly. You should have only had two terms that were like, and then the rest were unlike terms. The last thing I want to talk about in this learning target is some modeling. So when is this useful? How can we apply this to maybe some context? And I think it's really important that you guys get your language skills up when you're reading a word problem. So let's take a look at this gardening problem. Trina's building a garden. She designs a rectangular garden with a length of x plus 4 feet and a width of x plus 1 feet. When x equals 4, what's the area of her garden? So I always draw a picture, right? So let's draw her garden. She has a rectangular garden. One side is x plus 4, and the other side is x plus 1. We want to find area, so we have to multiply these. Well, that's convenient. We can turn her garden into an area model and multiply. We're going to worry about this in a second, the whole when x is 4, but we're first going to multiply these two things together to get an expression, okay? So I'm going to x squared here, 4x here, x here, and 4 here. So I get a polynomial when I combine like terms of x squared plus 5x plus 4, okay? And now the question is saying, well, when x equals 4, what's the area of her garden? So I know that this expression represents the area. So, right with this x equals 4, that means I need to plug it in. So I'm going to have parentheses when you plug things in, 4 squared plus 5 times 4 plus 4. 4 squared is 16. 5 times 4 is 20. 16 plus 20 is 36, and 36 plus 4 is 40. My units are going to be feet squared. Whenever you multiply two units of measure together, they become squared. So it's not 40 feet, it's 40 feet squared is your final answer here. Okay, so not so bad. We're just applying what we've learned to some context. Okay. The next one's a little bit trickier. Auric has designed a rectangular mural that measures 20 feet in width and 30 feet in length. Laura has also designed a mural, but it measures x feet shorter on each side. So here is, let's draw a picture. So here is Auric's mural. It's 20 by 30. Okay? Now Laura has made a mural, but each side is shorter. So if a side is shorter, we're going to be taking measurement away from that side, which is a form of subtraction. Right? You're taking that measure away. So one way we can describe Laura's mural, and I'll draw smaller, right? So her mural is smaller than Auric's. So if Auric said 20 here, then Laura is 20 minus x, because we're taking some amount x away from 20. If it's 5 feet shorter than Auric's, then it'd be 20 minus 5 to be 15, right? So each side is x shorter, so one side is 20 minus x and the other side is 30 minus x. Okay? So now I'm going to redraw this bigger because now I know that I've got 20 minus x and 30 minus x, which I've just learned I can multiply by creating an area model. Okay? So now I'm going to do the math. 20 times 30 is 600. 30 times negative x is negative 30x. 20 times negative x is negative 20x. And negative x times negative x is actually positive x squared, right? A negative times a negative is a positive. So now when I combine like terms and write in standard form, I'm going to go ahead and put the x squared first. I'm going to combine these two like terms to get negative 50x and then plus 600. So this is Laura's area. Okay. Now it's saying, well, what about when x equals 6? What's the numeral? Like, what's the numeric area for her mural? So now we're going to take 6 and plug it in for wherever we see x. Okay. 6 squared is 36. 50 times 6 is 300. Scroll down. Order of operations says that I have to do 36 minus 300 first. So 36 minus 300 is negative 264. And then negative 264 plus 300 is 336. And then the unit would be feet squared. Okay, so a little bit more complex, a little bit more critical thinking. This part here of drawing the rectangle is super important, right? Drawing that picture and understanding the idea of making something shorter means we're subtracting. If we had said that Laura's area was 8 feet longer, then we do 20 plus x, right? Those words mean something. Those adjectives and description words, they matter, okay? So read really carefully when you do a word problem, all right? That's about it for this learning target. Good luck on your practice, and ask for help if you need it, please.